Now that we know some of the basics of logarithms, let's look at some of the properties and how they're used. So with exponents, we know we have three main properties. We know that when we multiply things with the same base, we add their exponents. When we divide things with the same base, we subtract their exponents. And when we raise a power to a power, we multiply the exponents. When we're dealing with logarithms, remember these are very similar to exponentials. They're actually the inverses of exponentials. They're very related, and so they should have some similar properties. And in fact, they do. So logarithms have these properties that are going to be very similar to these exponential properties that we'll now look at. Our first one relates to the additive property of whenever you multiply things with the same base, you add their exponents. And this says log base b of mn is equal to log base b of m plus log base b of n. So this is our related property. And we can use this. For instance, log base 2 of 8x would be log base 2 of 8 plus log base 2 of x. And this can be very helpful because, for instance, this log base 2 of 8, what this is really saying is 2 to what power is 8? Well, we know that 2 to the third power is 8, so that's just 3. 3 plus log base 2 of x. So we were able to actually simplify it some. We can also go the other way. Here I have log base 8 of 4x plus log base 8 of 2. Well, we can actually condense this and multiply. 4x times 2 would be 8x. So this is the same thing as log base 8 of 8x. So these properties do go both directions. Now that we've looked at our additive property, with exponents we had that when we divide we subtract exponents, so let's see its related property in logarithms. Here, if we're actually dividing something and taking the log, it's going to be related by a subtraction. As an example, if I look at the natural log of 4 over y, this would be the same thing as ln of 4 minus ln of y. And once again, this also goes backwards. So if I had log base 10 of 7 minus log base 10 of z, I could rewrite this as log base 10 of 7 over z. So once again, this property does go both directions. Our final property is going to be like raising a power to a power. And essentially it says if I have this exponent inside of a logarithm, I can just move it out front. As an example, log base 9 of x to the 4th would be the same thing as 4 log base 9 of x. And it also goes the other direction. 1/2 log base 6 of y would be log base 6 of y to the 1/2 power, which would be the same thing as log base 6 of the square root of y. So now that we have our three properties, let's look at a more complicated example that would actually combine all of these. Here I have ln of 12x squared over y to the 4th. So here the first property we're going to do is we want to get rid of that division sign. So we'll have the top minus the bottom, ln of the top minus ln of the bottom. We can now see this first term has a multiplication, and multiplication is the same thing as addition, so ln of 12 plus ln x squared, and we still have this ln of y to the 4th. And then from there we want to move exponents out, so 2 ln x minus 4 ln y. So now we've taken something and broken it up as far as we possibly can. So now let's try one that goes in the opposite direction. Here I have log x minus 4 log y minus 2 log z. So our first step should be that we want everything to have the same coefficient. So let's move exponents back up. This 4 becomes y to the 4th, and the 2 becomes z squared. We can now see that this subtraction means division, so I have an x on the top and a y to the 4th. I'm also subtracting this last term, which means it's also going to go on the denominator. So the abbreviated way to think about this is essentially positive stuff stays on the top, negative stuff moves down to the bottom.